we're going to do all of 9.2 today. Then we have 9.3 on the block, and we'll review on Friday. Quiz Tuesday. All right, so we're going to do the binomial theorem. This is going to show up in calculus a little bit. It shows up in other places too. Usually we just do to the third power, and people forget how to do that. So what's going to happen is we're going to take a binomial like this, x plus y, and raise it to the nth power. And we're going to write it all out. Of course, we do not want to FOIL the whole thing out, especially if we had something like 2x plus 3y raised to the 8th power. That would be a lot of work, right? Yes, it would be not be slight work. It would be the opposite of slight. So, but we're going to make it slight because we have some things to do. The first thing that we're going to do is called Pascal's triangle. Have you ever heard of Pascal's triangle before?
Why is it Pascal?
Well, I'll tell you why. It shouldn't be, because Pascal was a French mathematician. His name was Blaise Pascal. He was a Christian man. And he was in the 1600s. And it became his because he published it. He didn't come up with it. Yep. They have actually seen it as early as the 10th century in ancient India. And it shows up in China. And they call it, in China, they call it Yang Huai's triangle. Yeah, they don't call it Pascal's triangle. They give him credit. Yeah. Anyway, so it was published in the 15th century in a book. And this is what Pascal's triangle does. It's going to help us find the coefficients that go in front of when we expand the whole thing. So here's how you generate the Pascal's triangle. Put a 1 up top. Do you know this one, Pascal's triangle? And then you're going to go 1, 1 underneath of it. And now you're always going to start with a 1. And you're going to take the two numbers above 1 and 1. You're going to add them up and get 2 here. End with a 1. Okay. Write a 1 again. Take the two numbers above and add those up. 1 plus 2 is 3. 2 plus 1 is 3. And then another 1. And we can keep going. We can go as far as we want to. We go 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. End with a 1. Do it again. 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5, and 1. And if you notice, there's some patterns forming. 1, you can tell, is very symmetrical, right? Very symmetrical. The other thing is you can see this diagonal here is 1, 2, 3, 4, 5. So we're going to get 1, 6, 15, 20, 15, 6, and 1. Let's just do one more row. 1, 7, 21, 35, 35, 21, 7, and 1. Okay, so what they do is they call the first row, this row up here, they call this row 0. They call it row 0 because when you take, let's just take a simple binomial, x plus y, and if you raise that to the 0 power, you get 1. Now, this Pascal's triangle is a coefficient triangle. So if I take x plus y and I raise it to the first power, I get 1x plus 1y. That's the first row of Pascal's triangle. See how it's 1, 1? Coefficient 1, 1. Take x plus y and raise that to the second power. When you do that, you get, if you FOILed that out, you get x squared plus 2xy plus y squared. Do you see the coefficients? Coefficients 1, 2, 1. The next one is going to be x plus y to the third power, which is going to be x cubed plus 3x squared y plus 3xy squared plus y cubed. If I were to take that x plus y and FOIL it and then super FOIL, that's what I would get. And do you see where the coefficients are? 1, 3, 3, 1. Okay? What else do you notice? Do you notice that the exponents on x are going down while the exponents on y are going up? Do you see that? 3, 2, 1, 0. And this is 0, 1, 2, 3. The other thing you can notice is that the coefficient or the exponents always add up to 3 here. Okay? 2 plus 1 is 3, 1 plus 2 is 3, y cubed is 3, x cubed is 3. All right, so knowing that, let's go ahead and test it out. Let's take x plus y and raise this to the 6th power, and let's see if you can do it. So we're going to go to row 6 of Pascal's triangle, which is 1, 6, 15, 20, 15, 6, 1. This is going to be a lot. Are you ready for it? Okay, so we normally don't write 1. So we'll write 1 x to the 6th plus, the coefficient is 6, and x's are going down while y's are going up. The next one is going to be, let's see, it's 1, 6, 15, x to the 4th, y squared. Take 1 off of x and give 1 to y. The next term in it would be 20 x cubed, y cubed. That's the center of it. It's when they both are equal to each other there. And then we go 15 x squared, y to the 4th, plus 6x y to the 5th, and then finally plus y to the 6th. Wow. How would you like to FOIL that out, Ben?
I would love to.
No, you wouldn't. That's the answer. We did that very quickly, huh? Okay? So notice some things here. This 1, 6, 15, 20, 15, 6, 1 come from Pascal's triangle. Okay? The exponents of x are going down while the exponents of y are going up. They always add up to whatever the power is. Oops, here. The power is that you're taking the power to. Okay? So it's not too bad. You like it? Okay, here we go. Number 1. Now, of course, we're not just going to have x and y. We're going to have some numbers in there that we're going to have to deal with. So here's how you do a very basic problem. Here it is. We're going to take 2x plus 3, and we're going to raise this to the 4th power. Okay? 2x plus 3 to the 4th power. So here's the way I like to do it. First thing you need to do is you need the coefficients from row 4. So on your paper, when you're taking a quiz or test, you're going to quickly do Pascal's triangle, or there's another way I'm going to show you in just a minute. And you're going to write down row 4. So row 4 is what? 1, 4, 6, 4, 1. Give yourself some room to work with here, okay? And now what we're going to do is we're going to take the first term in your binomial, which is 2x, and 2x is going to be raised to the 4th power. And then 2x will be what? Cubed. 2x is then going to be squared. And then times 2x to the 1st power, which is just 2x. Okay? Then I'm going to take the second term, which is 3. This is like my y, you know. And so y is going to have no y here. And then 3 to the 1st power, 3 squared, 3 cubed, and then 3 to the 4th. And in between all of them, I'm going to put pluses because my middle term is plus. Okay? And now I need to just simplify these things. So my first term is 2x to the 4th. 2x to the 4th is 16 x to the 4th. Okay, got to go 2 to the 4th and x to the 4th. My next term will be, and you're going to need your calculator, you're going to go 4 times 2 cubed times 3. You get 96 x cubed plus, this one I'm going to do 6, 2 squared, 3 squared. 2 squared, 3 squared, and I get 216 x squared. Over here I have a 4 times 2 times 3 cubed. What's that? 216 again. So 216x, and then 3 to the 4th is 81. Done. There you go. We expanded that whole thing up. Lost?
Yeah.
Really? Oh. What? Okay, so we're multiplying. If you're multiplying, like, let's look at this term right here. If you're multiplying, you're going to go 6 times, this is 2 squared and x squared. So we go 2 squared, x squared, and 3 squared. So how do I get the number? I go 6 times 4 times 9, and then the x squared is on there. So that's all I was doing, was putting those numbers in. Let's do another one. Number 2. Number 2. Hi, kids. Are you having a good day? Yeah. Thanks for coming.
Thank you.
Yeah? All right, number 2. Let's do one with a minus in the middle. X minus. Hi, kids. Come here. I need job security. All right, to the 3rd power.
If they come in again.
Hello.
Yeah. Yes.
Okay, here we go. Let's do one with a minus in the middle. Now, here's how you start.
Here's how you start.
You gotta continue. You can't.
I should no, I don't like it. When I used to work at Polly's, there was this guy, his name was John, but he'd always go up to the table, hey folks, how you doing? My name's Joey. And it was so funny, and I was like, his name's not Joey.
Was he really funny?
Yes.
Wait, I think I had him as my waiter one time.
No, this was like 20 years ago.
Okay,
Yeah.
He's still there.
No, I think he lives in Arizona. Okay. Anyways, here we go.
He lives in Arizona.
He was alive.
I'm friends with him on Facebook. All right, we're going to go 1. First what you do is you look, this is the cubed. It's being cubed, okay? So you go to the 3rd row of Pascal's triangle, which is 1, 3, 3, 1. Okay? Yes. That's your first step always. Whatever it's being raised to. The 4th power, go to the 4th row and write those numbers out. 5th power, good. It's making sense. Okay. Now my first term here is x. Okay? So I'm going to go x cubed, x squared, x, and then nothing on the end. Okay. My second term, the whole thing is 3y. Ignore the negative for now. Okay. 3y. So there's nothing here for 3y because x has all the 3's. Here we're going to go 3y to the 1st power. Then we do 3y squared. And then we do 3y cubed. Okay. So these are going down, x, and these are going up. And now what you're going to do, because it's minus, you're going to alternate plus minus, okay? The first term is positive. That's this one, x cubed. The second term is negative, positive, negative. That way you don't have to deal with the negatives in there. You just alternate positive, negative, positive. And now we need to fix everything. So my first term is 1x cubed, which we write as x cubed. The next one, see what I'm multiplying together? I'm multiplying a 3 times x squared times 3y. What does that give me? 9x squared y, perfect. My next term is 3 times x times 3 squared times y. That gives me 27. 27xy squared. So because 3 is squared and then times 3. And then my last term is 3 cubed times y. So minus 27y cubed. And that would be the answer. Okay? Well, not at first. At first, yeah.
How do you know when to do plus or minus?
Oh, because this was a minus right here.
When it's minus, you alternate?
Yes. So this in the middle was plus, and so they're all pluses. But when the middle is a minus, you alternate plus, minus, plus, minus. You start with plus on the first term. Okay, part B. Now, how does this tie into what we did yesterday? Right here. Here it comes. You can also get the coefficients of Pascal's triangle by doing NCR. Okay? NCR. Also, by the way, in your book, 8C2 is the same thing as this. Okay? It's a different notation, but it means the same thing. All right? And you know how to find that on your calculator. It just looks weird, but that's what it is. So for example, if we were to go and do x plus y to the 6th power, and let's say that, I don't have Pascal's triangle in front of me, then this is what you can do to find the coefficients. You can do this. 6c0 x to the 6th plus 6c1 x to the 5th y plus 6c2, do you see the pattern? x to the 4th, y squared. Remember, the x's are going down, the y's are going up. It's 0, 1, 2. What's the next one going to be? 6c3 x cubed y cubed. Okay, the next one? Yep, 6c4 x squared y to the 4th. And then I'm just going to go dot, dot, dot. 6c6 y to the 6th. Okay, that's how you can get Pascal's triangle also, the coefficients, by doing combinations. Now, let's notice a couple of things. Okay, let's look at the third term. This is the third term right here. Okay, the third term is 6c2 for the third term. X is to the 4th, and y is squared. Now notice things that match up here. First of all, the third term is 6c2. It's not 6c3 because you start at 0. 0, 1, 2. Okay? Also, the other thing is, whatever this number is will be this number. This 2 will be also that 2. And then this 4 plus 2 will make 6. You have to add up. Okay? So when you add up 4 plus 2, it gives you that number right there. Now, here's what you're going to do in your calculator. Let's say we want to find the 4th row of Pascal's triangle. This is what you can do. Go to your calculator and go 4c bracket, not a parenthesis, bracket, 0, 1, 2, 3, 4. It will give you Pascal's 4th row. I'll show you how that looks on here. I go to Math, PRB. Oh, wait, I'm sorry, I forgot to put 4. 4 Math, PRB, NCR. The bracket is right above the parenthesis. So I'll go bracket 0, comma 1, comma 2, comma 3, comma 4. Close the bracket, hit enter, and there it is. That's the 4th row of Pascal's triangle. 1, 4, 6, 4, 1.
Where is it again?
Okay? So you'll hit 4, go Math, PRB to NCR, and the bracket, you can't use parentheses, you have to use brackets. They're right above the parentheses. Do you see it? And there you go. Comma? Oh, comma is right here, comma button, right next to the parentheses. So let's say I want the 6th row. Okay, here's the 6th, this is the 6th row right here. I'm going to go 6 Math, PRB, and then I do bracket 0, 1, 2, 3, 4, 5, 6. Close the bracket. It'll give me the 6th row. It doesn't show all of it. You have to arrow over. Because the 6th row is pretty long, right? 1, 6, 15, 20, 15, 6, 1. You have to arrow to see the whole thing on your screen. All right, that's just another way to find the whole row if you want to find it without doing Pascal's triangle. Yeah?
My calculator said error. I typed in.
So did you do bracket? And you did commas? Yeah, I'll look at that in just a minute. Let me do this real quick.
Okay.
All right, number 3. Maybe the new calculators don't do that. Did anyone get a new calculator? Did it do it? It did over here. Okay, you probably just plugged something in wrong. I'll look at it though. All right, number 3. It says here that we have x plus 2y to the 8th power. Okay? And we're not going to expand this whole thing. That'll take a while. We want to find one term. We want to find the a x cubed y to the 5th term. Or basically, we want to know what's the coefficient going to be when I have this whole thing expanded out. What's the number that's going to be in front of there? It's kind of like asking, you know, what's this? What's this number in front of the xy squared going to be? Okay? It's just like that. All right, so here we go. This is what we're going to do. We're going to use a combination. Okay? The number that we have here is to the 8th power. So that's the number I'm going to use. 8c something. Now remember what I just told you. Remember what this number matches with? It matches with the y. It's going to be 8c5. X is going to be cubed. And the y term, which in this case is not just, this is x, this is 2y. 2y is going to be raised to the 5th power. And so to find the coefficient that goes in front of x cubed y to the 5th, we have to take 8c5, multiply that by 2 to the 5th, and then we'll get x cubed y to the 5th. Okay, so we go to our calculator, 8c5, and then times 2 to the 5th. And we get 1792, yep, the year I was born, x cubed y to the 5th. One time I was all, ooh, 1792. Columbus sailed the ocean blue. And they're like, no. The Declaration of Independence was in 1776, so you're dumb. I was like, yeah, you're right. Okay, number 4. The only history I like is the history of mathematics, and I took it twice because it was so good. The early history and then the modern history. They're different classes. I didn't fail it. Okay, let's try another one. How about this one? 3x minus 2y to the 7th power, and I want to find a x to the 4th y cubed term. Okay, if I were to expand this whole thing, somewhere down the line, there's going to be an ax to the 4th y cubed term. It's actually going to be the 4th term. So here we go. We're going to go with 7, okay, because it's raised to the 7th power. 7c what? 3. Good. 7c3. It's always whatever is on y, on the second term. Sometimes the second term is not y. And then we're going to take 3x. That's going to be raised to the 4th power to give me an x to the 4th. Don't forget the 3, though. 3 goes with the x. And then we're going to do negative 2y to the 3rd power. Okay? And this, like I said up here, see how 6c2 is the 3rd term? Did I say 4th? Yeah, 7c3 would be the 4th term because it's going to be 7c0, 1, 2, 3. That's the 4th term. All right, so here we go. 7c3, do that on your calculator, times 3 to the 4th times negative 2 cubed. Let's see what that coefficient ends up being. They're pretty big numbers, so don't be alarmed. Ooh, negative 22,680. So that would be the coefficient in front of x to the 4th y cubed. Would you like to expand that whole thing out? Me neither. Oh, Ben would. Okay. All right, and let's do one more because this one's a little tricky. Because this one's not going to have like a variable in the second spot, which gets a little complicated, but you can do it. Here we go. Suppose we have 3x plus 1 to the 9th power. Okay? And I want to find the ax to the 5th term. All right, so let's talk about this. We're going to have 9c something. Okay? I know that my x term is going to be to the 5th power. My y term would then be to the what? 4th power. So this has to be 4 also. See how there's no y here? It's because there's a 1. There's a number. There's no variable at the end. So people get kind of confused because they're like, there's no y. What is that? Is it to the 0? No. 1 has been raised to the 4th power. Remember, these have to add up to 9, and this number goes with that number. Okay, so then on your calculator, you would do 9c4 times 3 to the 5th, and then 1 to the 4th is just 1, so you don't even need to worry about that. 9c4 times 3 to the 5th equals, my salary last year, $30,618.
That was your salary last year?
Felt like it. All right.
Was it really?
No, I make a lot more than that. A lot. Like a lot.